Hello, this video is an attempt to try to explain the difference between lurking variable and confounding variables. It's just a common question that we get a lot, so I just want to try to clear it up a little bit. Don't worry about it too much. The basic answer between the difference, which, if you're really having a big struggle with this, which you can always kind of rely on, is we normally talk about lurking variables when we're talking about regression lines and we're doing a scatter plot. That's normally when we talk about it. And then we talk about confounding when we're trying to set up experiments and we're doing experiments. So if you really are lost, that's kind of the ground foundation that you can try to hold on to a little bit. Lurking variables mostly for scatter plots and regression lines, confounding for experiments. But what's really going on is they're really related. They're kind of the same thing. It's just different situations. So if this is a good example here. Like, let's say you have the number of hours you study and then grade on your test. So I could go and I could make a scatter plot and I could ask people, well, how many hours do you study? And then I could look at their exam and look at their score over here, right? And say, what was the number you got on your test? Did you get an 80% or 90% or something? And we could get some scatter plot that shows an association with, hey, look, the number of hours that you study affects your grade, right? The more hours you study, the higher your grade is. And you'd feel all great about that. But you also got to realize that no matter where you are at on the x-axis for the variable hours, studying is not the only thing that helps you get a good grade, right? Some people study for hours and hours and hours and still get kind of mediocre grades. And some people don't even study at all and get really good grades, right? So we could have some people with some variation. So what else is going on there? Well, the other things that are going on, like intelligence, or how much you like the subject, or how good your teacher is, or how much sleep you got the night before the test, all right, all these kind of things. These are all lurking variables. They're variables that you're not including in your scatter plot. You're only looking at the number of hours to try to explain the score. I could take that and get the residuals and then plot the residuals against your IQ score, and then I could take that result and plot it against how many hours you slept, and I could take that and plot it against a scale on how much you like math, and so I could add in all these variables. But until I do, they're lurking. They're just in the background. They're affecting what you see in the scatter plot, besides the hours. And this is back to the coefficient of determination. If we had an r squared, a coefficient of determination that, let's say, was 0.8, now I'm saying 80% of the variation in scores, math scores that I see, can be accounted for by the number of hours the student studies. But there's this 20% that really isn't accounted for. There's still some variation along the way, right? There's some variation along the way. So I still have variation, and that extra variation is because of lurking variables. There's other variables out there that are lurking behind the scenes that makes it look like there's some kind of association. So sometimes it's stuff you expect, but sometimes it's things you don't expect either. Like I showed the video about polio. Back in the day, they thought that the more ice cream that you ate, that you had a higher chance of getting polio, or polio would act up or whatever. And of course, that's not the case. The lurking variable was that it was summertime, and for some reason, polio was being active during the summer hot months, when the temperatures are warm outside, and it had nothing to do with ice cream. So that's really the heart of what a lurking variable is all about. Is like, we think there's some association between two things when really there isn't. It just looks that way because this lurking variable is telling us there is. All right, so that's kind of lurking variable. Now, in order to get rid of that problem, like in order to reduce the variation as much as possible, and also to try to hone in on what is really affecting something, we do experiments. experiments are the only way that you can prove something causes something else. You can prove causation, right? So we're trying to say, is this really a cause? Is this really what's doing it? It's the only excuse me, it's the only thing that's causing what you see in the change in grades. And of course we know that's not true because you have other things going on. So we try to eliminate it, right? So in experiments we do things like blocking, like maybe you're trying to look at the dissipation time of a medicine in the bloodstream of people. So you don't want a person's race, like their genetics because of their race, or their genetics because of their gender, or other types of genetic differences. You don't want that to mess up your results. You want to really isolate one thing that's different and measure that and say, and then if you can, then you can say that's the cause, right? Where everything else in your experiment is exactly the same for all the subjects, all the people in the experiment or things, and there's only one thing that's different. There's one level of medicine, like this group is taking 20 milligrams where the other group is taking 50 milligrams, and you're just changing one thing about that, and not anything else, right? So that's what you do in an experiment, is try to prove causation by isolating everything else. So to get rid of these lurking variables, and so to not allow something to confound your results. So I'm trying to introduce this word confound in here now, right? So if you have, let's say you just group men and women together and then you do this drug experiment, well, it's possible that women's bodies react and maybe, I don't know, dissipate or get through the medicine differently, right? Maybe faster, maybe slower than men. So in order to get rid of that lurking variable and to get rid of confounding in my experiment, right? I don't want anything to confound my results. I don't want anything to mess up my results. So in order to get rid of that, we'll do blocking, and we'll block men and women first, and we'll separate them out. And then within the women, we'll have two different groups. And within the men, we'll have two different groups, right? Instead of just mixing them together. And you could do the same thing for all the races. We're going to separate all the races. We're going to separate the genders. We're going to separate people who are obese and people who are normal, in the normal range, and people who are underweight, right? And we'll separate those into groups. So like you really want to separate and control, we use the word control a lot, control everything you possibly can, so that what you see in your results, you kind of know that it's only coming from this one thing that you were looking at, right? It's only coming from the different levels of medicine we gave them or something like that. So they kind of go hand in hand, because in an experiment, you can have lurking variables, but you're trying to reduce lurking variables so that you don't have something like a lurking variable confounding your results and causing confounding, where you're trying to isolate one thing, but you end up with two or three things affecting your results. You don't want that. You want one thing changing and everything else the same. So that's where we just use the word confounding, because we don't want other stuff to confound our results. We only want one thing affecting our results. In lurking, you can have many lurking variables, and sometimes you know what they are, sometimes you don't. Sometimes you think there's something going on, but really there isn't, because you have lurking variables. And when we do scatter plots, that's why we never say something causes something. We never say that, because we're always aware that there are lurking variables, like almost always. We're not trying to eliminate those lurking variables. We're just taking it at face value, right? Versus an experiment, we are trying to eliminate all those lurking variables so that we don't have confounding in our experiment. I hope that's clear as mud. Just kidding. Hope it's clear. Thank you.